Okay, so we're taking a look today at amortization, right? What this is the process of gradually reducing a debt over time through regular repayments. So basically, you'll be using this for repayments, for mortgages, for pensions, anything that's going to be giving out a regular repayment to you, okay? Or the other way around, sorry, or you're doing a regular repayment to something, okay? So pension, you can imagine, is like a regular repayment to you. Mortgage is kind of a repayment to something else. So you can find it on page 31 of your formula booklet. It's this bad boy here. And the A stands for the annual repayment amount, or it could be monthly or it could be weekly, depending on what the question tells you about the compound interest. And P is the principal, the initial amount that you had in there. Now, this works off the principle that the money that you receive in the future is like a future repayment of A, and its value today would be given by the following. So like, to get the value today of what a future repayment would be, assuming that you have money that gains interest, if you say have it 1 year away, then it would be whatever you wanted to have divided by 1 plus I to the power of 1. The second year, it'd be the same idea, but this to the power of 2. Okay, so basically for example, if I had €100, and let's say we're saving it at 5% yearly interest, right? I don't actually need €100 at the start there. I need 100 over 1.05. So I'd need to have €95.24 roughly in my account. And then by the end of that year, it would be worth 100. Okay, so that's the kind of idea there of where that's coming from. So that said, though, you don't need to derive that or do any of that. This is kind of taken as known. So continuing on, I would do these until I am repaid off the whole sum of money after a certain period of time. So if I'm repaying a mortgage, it's how much I've paid after the principal amount that I've paid after that certain period of time. Now, what you're going to spot here, or hopefully see, is that we can turn this guy into this equation. And that's the first thing I'm going to tackle. So in 2017, question 8, for example, they gave this question: when a loan P is repaid in certain amounts, blah, 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 show that it becomes this, show how this formula is derived. So, and he says, you may use the formula for the sum of a finite geometric series. And that's like saying, well, yeah, you have to. But here we go. I'm going to copy this idea that I took up here. So this is where we're going to start. We're going to start with this idea. And what I'm going to do here with this is I'm going to say, okay, now that I have that, let's factorize out the A. And we get to this part guy here. Now, what we need to spot in this sequence is that this is actually a geometric sequence. We have a term. The next term is actually just that term multiplied by itself. The next term after that would be that term multiplied by itself again. So we get the following kind of relationship. Our A is this guy here. Our lowercase r, our common ratio, is also this guy. And our time here is just t, because we don't know for how long it's going on for. Now, what we need to do is we need to say, take this guy. They're all being added together. Okay, so that is leading us to the idea of a sum of a geometric sequence. So in here, you can find on page 22, the sum of a geometric sequence is a by 1 minus r n all over 1 minus r. So over here, I'm going to say, okay, P equals a, big square bracket, times 1 over 1 plus I, that's my small a, by 1 minus 1 over 1 plus I to the power of n, in this case it's t, all over 1 minus 1 over 1 plus I. Okay, we're actually done most of the heavy lifting at this point, but this part is where people get upset with the algebra and the rearrangement. So what I'm going to do first is I'm going to say, right, what's this become? Well, anything to the power of t, it's t on top and a t on the bottom. So 1 to the power of t is just 1, and this becomes 1 plus I over t. I'm also going to clean this part up and make it a single fraction. So I'll do this in stages. So here we get 1 minus 1 over 1 plus I to the t. All over, I'm going to multiply top and bottom of this one by 1 plus I, so it becomes 1 plus I minus 1 all over 1 plus I, because they now have the same denominator. Next, we're going to multiply the top out. So this by this, and then this by this. So P equals A times all this guy, so it becomes 1 by 1 plus I. Top of the fraction by the top of the fraction, bottom of the fraction by the bottom of the fraction. So on the top here, we're going to get 1. On the bottom, just over here, when you do 1 plus I times 1 plus I to the t, you have to remember that this is 1 plus I to the power of 1. And when you've got two indices, you can add the powers if they're the same base. So here it becomes t plus 1. All over. 1 minus 1 disappears and we get this guy here. Now, at this stage, we're actually nearly done, even though it doesn't look it. But what we're going to do is we're going to multiply, and this is the kind of key of the whole rule. I'm going to say here, boom, 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 boom. This is the thing I would forget. Multiply top and bottom by 1 plus I to the t plus 1. Okay, and a reminder actually, even though I just said it, I'll put it back here. Disclaimer, 1 plus I to the t by 1 plus I to the 1 equals 1 plus I to the t plus 1. Okay, so I'll put that all. You don't need to put that. I put the stuff in blue here, but this is just for you. Now, how's that going to help? Well, if I multiply this part of the fraction by this, what you'll notice is I'm really multiplying it by this. So what will happen is the 1 plus I in the bottom will cancel with the 1 plus I, and this will just leave me with 1 plus I to the t. So 1 plus I to the t. Over here, 1 plus I to the t plus 1, if I multiply top and bottom, they're just going to cancel, leaving me with minus 1. On the bottom, if I multiply this whole fraction by this, really what I'm doing is I'm multiplying it by this. So on top, what's going to cancel top and bottom is this guy. And we get I by 1 plus I to the t. Now you don't need to show those in, like you can just show the step I showed from here to here. I would write this for the examiner what you're doing, okay, because it's a bit of a leap. Last step then, all we're going to do is we're going to multiply the right by this. And if we multiply the right by it, we have to also multiply the left by it. And then we're going to divide by this to get a on its own. So a becomes p times I by 1 plus I to the t all over 1 plus I to the t minus 1. And that is our amortization formula derived. Okay, let's just walk through that whole thing again for 2 minutes. So back to the start. Start with the geometric sequence. Okay, take out the a and see that it is, now it's got your geometric sequence, and it's the sum of a geometric sequence. So we need to identify our small a, our r, our t. We plug it into the formula. What formula am I plugging it into? The sum of a geometric sequence formula. There. And then the difficult part is the rearrangement and neatening up. So just take your time going through the rearrangement. And then here, the big guy that people forget is to multiply the top and bottom by this, so it kind of neatens it up nicely. You should get down to that. As I said, that can be a past paper question. It was 27, question 8, 2017. So let's take a look at applying it. 2022, the deferred paper, question 7. Mark and Aisha buy a house for $280,000. They pay 15% of the price from their savings. They take out a mortgage for the remainder. The mortgage is 25 years at this interest rate per month. Work out their monthly repayments given that they're annual each year. Now, we can do this 2 ways. We can do this with the formula, or we can do it with the sequence. I'm going to do it with the sequence first, just so you can see it. Again, feel free to try this question and then have a look at the solution. But what I'm going to say is the principal amount is a over 1 plus I to the power of t. Now, we have some numbers. Actually, I'll just take my time. Plus a over 1 plus I squared plus dot 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 plus a over 1 plus I to the t. So let's plug in our numbers. Oh wait, we need to check something. The house was 280,000. So really the principal amount here is 280,000, but they're only paying off 85% of it. So this number here is 238,800. Over here, I don't know the amount, that's what I'm trying to find, and the monthly rate is 0.36. Just be careful here, 0.36% is 0.0036. And when I say 1 plus that, I get 1.0036. I also took a look here, 25 years. 25 years is 25 by 12, which is 300 months. So I've done t as 300 there. My next stage, this becomes 238,000. Factorize out the a. So we get down to a is this value, our small a. Too many a's here. R is this value. and our t is 300. So we're ready to use our sum of a geometric sequence again. I'll call it that guy. Down here in the next bit. So it's by, remind yourself if you need to, whip out the formula booklet, it's a times this guy on the top and 1 minus r on the bottom. Okay, now before you get tempted to plug this in the calculator now, I would avoid that because it's going to be it's going to be an ugly looking number, and then you might round a bit early in the question. So instead what I'm going to do is I'm going to multiply both sides by what's in the bottom here. So I'm not actually going to do it, I'm just going to write it 238000 times this guy. And then I'm going to divide both sides by what's on top. And again, I'm not actually going to do it, I'm just going to write it down here. I'm going to say this guy on top. All of that should equal a. I then grab my calculator and I plug it all in. And I get it to be 1298.683106. And we're dealing with money, so just check the question again. This question said to round it to the nearest cent. So sometimes it'll say nearest euro, sometimes it'll say nearest cent. Take your time, read the question. Done. So that's using the sum of a geometric sequence to solve it. What if I use the formula, Steve? Okay, well, let's use the formula. So take the time to identify your amounts. We still got that 2380 because they paid off the first bit themselves. The interest rate in this question was 0.0036 and the time was 300. Let's have a look. Grab your calculator and plug it in, and sure enough, you get the exact same answer as last time. How nice is that? Okay, which method is faster? Obviously the second one, way faster. But what I do recommend is going through this method a few times with the actually doing the sequence so that you can kind of understand where it's coming from. Because sometimes when you interpret the question, you might feel like, oh, I don't really know what I'm looking for with the amortization, and you forget after doing it a few times how it's created. It'll also help you learning it to do it the long way. Right, let's have a look at one other year. So in this one here, I'd recommend pausing it, trying the question yourself, and then seeing if you get it right. This time here, though, I'm going to use both methods again and just talk our way through it. So, as always, I say 1 plus I to the 1. And I'm paying 250,000 mortgage. They tell me the monthly rate is this, so a reminder that's 0.00287. So this is 1.00287. And the amount of months looks like it was 25 years again, so it's 300. See that that's the sum of a geometric sequence, the SN formula. Where am I getting that again? Bing, this guy here. And let's apply it. So what's my A? Let's identify these guys out. So A is this, R is the same, and my T is 300. So plug in your A, your first term, your r to the power of n, or t here, but t is 300. Again, multiply top and bottom by this guy. Multiply both sides by this guy on the bottom, and then divide both sides by whatever's on top here, and you get down to here. Let's plug it in and find out. And I get this to be 1244.063 and some change. Check the question. It said to the nearest cent again, so perfect. And let's just try it once real quick with the amortization formula. So we've got our principal, our interest, our time. We're going to plug it in, show it filled in for the examiner. Get yourself those attempt marks. And then plug in your calculator. And hey presto, shockingly, I get the exact same answer. Wow. Welcome to Leaving Cert Maths. Okay, guys, that's it there for covering amortization. Hope you found that useful. If you did, then like or subscribe, or check out the other social medias where I'll be adding extra resources. If you want something particular made, then just leave me a message on one of those platforms and I'll do my best to get back to you at some point. Best of luck in all your exams.